Alright, here we go. Lesson 11.6, and this is exponential equations and change of base. Let's call it A, just to be on the safe side. Intermediate algebra, and this is the last lesson of this chapter, so this is it as far as logarithms are concerned for you, at least this year. Alright, so what we're going to do is look at something a little bit more equation-ish. So let's say that we have 5 to the x power equals 12. So what we're trying to do is find out what number goes on 5, so that if we take 5 to that power, we're going to get 12. Well, what do we know? We know that 5 to the first power is 5, and we know that 5 to the second power is 25. Well, we're looking for 12. So that's between 5 and 25, so that means my exponent is going to be between 1 and 2. So it's going to be a decimal, so I can't just figure it out really quick and easy. So that's where logarithms come in. So what I can do is when I'm given this kind of a problem, I'm going to rewrite it by putting a log on both sides. Okay, see what I did there? All I did was, given an equation like this, all I did was put a log in front of both of those. Alright, now what do I know about logs? I know that this x can be moved in front. Okay, so that's not too bad. Now let's just do some simple algebra. If I have two things multiplied together, how do I get rid of one of them? I divide both sides. And that gets rid of that. So what do I have? X equals log of 12 over the log of 5. Take your handy dandy calculator and type in the log of 12. And you get 1.0792, and the log of 5 is 0.6990. Divide those out, and you will end up getting an x of 1.5439-ish. And that is your answer. That is the number that goes on this 5 that will give me 12 as an answer. Alright, so let's look at a few more of these. Okay, so remember how I said solve these? Put a logarithm on both sides. Now I could have put an ln, I could have put a natural logarithm. It doesn't really matter, nothing's going to change if I do. But let's just stick to the common. Take that and put it in front. Let's put it in parentheses there. Okay, now remember we did on the last one, we took that, divided both sides by the log, 25. And what happens? That cancels with that. And we're left with 2x plus 1 equals log of 15 over the log of 25. Okay, so what do you do with that? Well, let's take the log of 15 and the log of 25. Log of 15 is 1.1761. Yeah, I have these memorized, right? 1.3979. Okay. Let's move all this up a little bit. Alright, so I divide that out. And when I divide that out, I get 0.84. I'm just going to round it to 4 decimals. Subtract 1 from both sides. So, 0.8413 minus 1 gives me divide by 2, divide by 2, and I get an x value of negative 0.07935 for an answer. Okay? Nothing really crazy there. It's just remembering to take the log of both sides, and then life is good. Alright, let's look at example 2. How long does it take for $5,000 to double if it is deposited in an account that yields 5% interest compounded once a year? Alright, right above that, example 2, you should have a formula that looks like this. Okay, so A is basically, let's put it over here, is amount. So A is amount, P is principal. Principal means how much money you started with. R is your interest rate, so I'll just put a percent there. And you write that as a decimal, not as a percent. N represents how many years this money was, how many years it was compounded. And T is going to be, well, in this particular one, what we're looking for. But T is basically the time, how long it takes. So, alright, so let's take the problem and start filling in the letters. So how long does it take for $5,000? So $5,000 is our principal. In fact, what I'm going to do is I'm going to move this problem down because I'm going to need more room. So $5,000 is your principal. 1 plus, what is the interest rate? 5%. So 0.05 over N. Once a year. It's compounded once a year. And then N up here is 1, and T is what we're looking for, so we don't know that. And the amount. What does it say about the amount? How long does it take for $5,000 to double? So the amount we want to end with is going to be double the $5,000. So notice what we have here. Everything is filled up except we don't have a T up there. Alright, so let's go ahead and do what we can. So let's move all of this. I'm going to make that, oops, come on Gary. Move that smaller so I have that over here to look at, and move this up. Okay, so we have $10,000 equals okay, so I just added that together, and then I can take my 5,000, divide it by both sides. So I have 2 equals 1.05 T. Okay, so now I've got everything down to some little tiny equation. In fact, I have a T there. I'm going to make these both logs, both sides logs. Okay, now I can take that T and put it in front. Okay, so the key thing here is once I have my equation, if I'm looking for my exponent, I just have to make both sides logs. Okay, let's get this up here. Now that I have that, log 2 equals T. Okay, so I'm going to divide both sides by the log of 1.05. Oh my goodness, there's dogs outside our door. We're right next to the dog run where all the dogs come and poop. So, holy cow, they're noisy. So, log 2 over log 1.05 equals T. So now all you have to do is take the log of 2, the log of 1.05, divide those out, and you'll end up getting 14.2 as far as how many years it's going to take for that $5,000 to double. Okay? Alright, one more section here and we'll be done. So I'm at 10 minutes, so let's go ahead and make another video. Okay, in this last part of the lesson, we run into some trouble. And, you know, we had mentioned we're only going to use 2 different logarithms. One is a log base 10, which we just write it as a log, and a log base e, which we write as just ln. Okay, so those are the only 2 options you have for your calculator. If you wanted to know the log with a base 2, you can't do it with your calculator. Your calculator only does base 10s and base e's, so you don't have any other options here. So if I asked you to find the log base 8 of 24, that is saying what exponent can I put on 8 that's going to give me 24? Okay, your calculator will not do that because of this 8. So there has to be a way to figure this out. Okay, so we've got a handy dandy formula here, and write this down. I'll put it in red here. In fact, let's get rid of all this junk and put the formula here in red. So if we have the log of, say, a, so something other than 10 or e of x. So that's kind of like saying the log 8 of 24. So how do I solve that? Okay, so here's the formula, and down below here, in this section here, I'll actually show you how to move the numbers around. Alright, so you take the log of bx and put it over the log b of a. So what this means is we're changing from this base to this base. And really, we're wanting to change those to 10s. You could change them to e's if you want, but e's or 10s. That's really all that b is going to be. So what is this going to look like? That is going to look like this. Log of x, which in this case is 24, over the log of a, and in this case it's 8. So now all you have to do is take the log of 24 on your calculator over the log of 8, and when you divide that out you get 1.5283. So that is the log base 8 of 24. Okay, so nothing, not really that hard. You just have to, for the most part, let's try another one. Log 6 of 18. We're going to take the log of the 18 over log of 6. Okay, log of that over log of that. Put it in your calculator, take the log of that in your calculator, log of that, and divide it out, and you get the answer. Now I could go through the proof on why that works, but I think you're more interested in just being able to do it. So let's stop there for 11.6a, and we'll do the application example 4, and then we'll do a couple problems in 11.6b.